idea. A box plot can often be used to identify skewness. A distribution of data is skewed if it is not symmetric. It extends more to one side than the other. That extension are those whiskers that where it's extending. Same thing with the histogram, the tail, or like the bell-shaped curve or histogram, the tail extends to the right or the tail extends to the left. So it gives it that skewness. But the problem is that sometimes when the other box plot wasn't really taking into the idea of outliers. So that type of box plot isn't really resistant. Again, we're going to follow all the same steps. All we're going to do is change the option of box plot. So everything is still the same. You need to know your quartiles, which the calculator does it for us. You would want to find your inner quartile range, because what's happening here is how do you know what an outlier is? You have to start thinking about, is there a cutoff point? If you're looking at a data set, let's say, for example, you're hanging out with friends, and most of your friends are, let's say, 18, 19, 20, 21, and then one of your friends, their little sister, is 12 years old or 13 years old, and they want to start hanging out with you guys. You need to start thinking, like, at what point is someone, it's probably not whatever, maybe places that you're going, they're not allowed to go. There's curfews that, there's laws out there for curfews for minors. So, like, at what point, if there were 17, would that be okay? 15, would that be okay? 13, 14, would that? And the idea is, like, where's the cutoff point? Like, where do you consider something being too big or too small? In terms of data values, like, when is it too big, too small? If you're looking at, let's say, money, for example, let's say someone that makes like 40,000, someone else makes for 42, 45. At what point do you consider making a lot of money? Is it after 50,000? Is it after 60,000? Is it after 80,000? Is it after 150,000? So the idea is, like, what is an outlier? So what is an outlier is defined by these two down here. This idea of the upper fence and the lower fence. You can think about them as your cutoff points. Meaning that if any data values are bigger than the upper fence, all those would be considered outliers. Whereas your lower fence, if any data values are smaller than your lower fence, those would be considered outliers. So it involves using Q sub 3 and adding this 1.5 times the IQR. And remember, the IQR is, like I said, when we first were looking here, we're only going to be using this. This is just for the sake of putting there, but that's the one we're using, the inner quartile range. That's the formula. It's a small formula that help us determine our cutoff points. This is a cutoff point from above. This is a cutoff point from below. Your calculator is actually doing that for you all in the background. So it's taking care of these multiplications and cutoff points. It's finding the Q sub 1, Q sub 2, Q sub 3 all for you. It's doing everything and creating this box plot. So let's see the difference between, this was the one that doesn't take any outliers into account. So maybe there's some data values. So we look at our data set. Let's find a bigger one. So here, if you look at this data set, you see how the speed is 0.8 and then 1.4. There's not too much of a difference between these. But then when you start looking over here, 9, that's pretty far off, but then 17 is pretty far off. Like, at what point, like, is 34 too big? I mean, probably this is gonna be an outlier, because if you look at all the numbers here, they're all within like 1 to 20. So they're all pretty close. There's a lot that are close as 1. There's a good amount in the middle. It's not just like 0.8 and then 14. Like, there's literally a little bit of everything in between. But this is definitely taking a huge jump from 1 to 20s to 70. So these, maybe 50, maybe even 43, just by observation, look like they're not really part of the data set. Who knows what happened during that day? Maybe they were just having good. And that's the idea of being an outlier, because it's not really following the pattern of everything else. They're significantly different. But what's too different? Like, do we cut it off at 24? At 25? 28? Definitely this would be an outlier. But that's the issue, is when you start deciding like what's too big, what's too small. And that's what the fences do for us. It gives us that definitive cutoff point. So let's see the difference. So I'm gonna hit second, y equals again. I'm gonna hit enter. But now, instead of the box plot on the right, I'm going to use the box plot on the left, the one that has the little dots in there. And then make sure you hit enter, because then it's switching these things. If those things didn't switch, then you have to make sure you hit enter. And make sure you put the correct list, and then hit enter on that. It's always going to have that frequency of 1. Leave that. What these markers here is just the notation of the outliers. You can either denote the outlier as a box, a little plus, a little square, or a smaller little square. But now I'm going to graph it just like how we did before. I'm going to hit zoom. Then I'm going to go, oops, wrong thing. I'm going to hit zoom. Then I'm going to go all the way down to zoom stat. And then I'm going to hit enter. And now you can see. So that was the box plot before. That's when we weren't worried about outliers. And this is the box plot now when you are worried about outliers. Whoops, sorry. So there definitely is a difference here. Now, before, it looked like it was skewed right. But here, I mean, it still looks like it's kind of skewed right, but it definitely looks a little more symmetric than this huge, long extension. So there's definitely a little bit of difference between them. Here's another one. Let's see. Let's try second y equals. So remember, hit enter here. Everything will still stay the same. But if you want to just redo it again, hit enter on that one. Let me switch this to second L sub 1. And then make sure you hit enter. So it knows that you're using a new list. And then same thing, I'm going to hit zoom. I'm going to go all the way down to zoom stat. Or you can just hit the number 9. You hit enter. And this one didn't really change too much. So let me hit stat. Edit. So here's my data set that I just used. Second y equals. Enter. L sub 1. I'm going to use a little bit of squares. I'm going to hit zoom. And then I'm going to hit 9. Just so you can see that 9, just hitting 9 works as well. And then I can hit trace. And there's my min. My Q sub 1. My median. Q sub 3. And then my maximum value. So Let's look at the other one again. So I hit enter. It's under L sub 4. Zoom. Hit 9. And then again, I can hit trace again. And it's going to give me the 5-number summary. But now this number, this isn't my maximum value. This is just the data value that is smaller than the upper fence. That's what that number is there. It's not actually, the whisker's not going to the largest value. It's just going to the largest value that's smaller than the upper fence. Or vice versa, in the lower fence, it goes to the smallest number that's bigger than the lower fence. Sometimes that will be the actual min or max, but you can see in this situation that that was not the case. But it still shows you all the data values that are outliers. So 43 was an outlier, 55.6 was an outlier, 71.3 was an outlier, and the 77.8. So we go back to our table. So I read them again. We had an outlier starting at 43. I don't even know where's 43 here. It's not even. Oh, there it is. 43 was an outlier. 55.6, 71.3, and 77.8. And again, that's what I'm talking about. How even though maybe 24 is still part of this data set, so is 25, so is 28. But then at what point do you start thinking like, well, okay, that's too big already. But 38 was still part of this data set. So if I try zooming in here, I go to this data value. That's still my outlier. But if I go to the next one, there's my 38.5. That was the last value. That the biggest value that's smaller than the upper fence, where the other ones were bigger than the cutoff point. If you want to know what was that upper fence, you have to do these calculations. You have to get what Q sub 3 is, which we know, because you can just go to I can hit stat, go to calc, hit enter on one var. L sub 4 is already there. I hit calculate, and I can go to Q sub 3, which is 21.5. Then I'm going to add 1.5 times the IQR. And if you try and find the IQR, again, it's just taking Q sub 3, which is 21.5, and subtracting it by 7.9. So that's how you calculate your box plot. That's the modified box plot. So a modified box plot is a regular box plot constructed with these modifications. A special symbol used as an asterisk or a point is used to identify the outliers, which we saw that. So again, I'll go back. Second y equals. Enter. Zoom. 9. Again, those are the special things. So denoting the outliers. The solid horizontal line extends only as far as the minimum data value that is not an outlier and the maximum data value that is not an outlier. So that's why in this case, the whisker went to the largest value that was not an outlier, which was still within the fences. And you'd have to calculate your fences to see what those numbers are exactly. But that's the end for 3.3. I didn't think it was going to take this long for this last little bit. Hopefully that makes sense. But let me give you some homework. All right, here's your homework. So it's from section 3.3. Again, I don't expect you guys to try to do this by hand. So if you know someone if you don't have the calculator, again, try asking the library or try to find a classmate that maybe you guys can like Zoom chat with each other, or use the call function on Instagram, and you guys can somehow share your calculators together. By no means do I expect you guys to meet up together. So maybe you guys can FaceTime, something, maybe WhatsApp, whatever it may be, that you guys can share the calculator somehow. But don't calculate them by hand. That might take a while for some of these problems. If you're using your calculator, it's not too bad. That's why I gave a couple more examples, just because some of these, the wording might be a little tricky. If you're having troubles with it, email me, DM me on Instagram. I'll definitely help you. Because I know one or two of them, the wording's a little interesting, but for the most part, the rest of them, it's what we did in the previous video and in this video. So other than that, thank you, and stay safe and stay healthy.